we're talking about rational expressions, which is just the same thing as saying like a fractional expression. And I just wanted to go over this little graphic that sometimes helps me. It's talking about whether you can divide by 0 or whether you can take 0 divided by something. So if you have a number divided by 0, that's a no. We cannot divide by 0. If we have 0 divided by a number, that is okay. 0 divided by any number is 0. So when we look at the domain is the x values of these expressions, we are looking for basically all real numbers except anything that might make the bottom equal to 0. We know that the bottom isn't allowed to equal 0. So we would say that the domain is all real numbers except for -3 for that first expression. Sometimes you'll need to factor those. Factor your denominator, and then you find that the domain is all real numbers except x can't equal -4 and -2. Both of those x values would make our denominator 0, and that's not allowed. Here we have a difference of squares we can factor. And even though the x minus 8 on the top and the x minus 8 on the bottom would cancel out, we still say that the domain is all real numbers, and we're going to leave out -8 and +8. So even though it would simplify, +8 still isn't a legit domain value. And when we talk about simplifying, I'm talking just about that for example, you can't reduce this 8 and the 16 because there's adding and subtracting here. The only time you're allowed to reduce is when things are multiplied. So that's the reason that I always start out by factoring, because then I have 2 times x plus 4 and x plus 4 times x minus 4. And if it's multiplied, then you are allowed to reduce, because it's kind of like taking a number divided by itself is just 1. So that's how we simplify these expressions. You want to factor first and then reduce. Now, even though I canceled out that x plus 4 factor, my domain would still be all real numbers, but we would leave out -4 and 4. So even though that doesn't look like it's a problem to plug in a -4 into our final answer, we know it would have been a problem up here, so we exclude it from the domain. So just keep going, we're factoring. Here I think I'd factor out an x first. So that bottom part winds up being 2x, x minus 3, x plus 1. That was on the top, so the x plus 1's cancel. The 6 and the 2 here, we can actually think of that as a 2 times x. So it's not like the 2 and the x are attached or anything. So you can reduce the 6 and the 2 to a 3/1. It's getting kind of messy, but what's left on the top is 3, and what's left on the bottom is the single x and the x minus 3. We would go back to the original problem to decide on the domain, all real numbers, except 3, -1, and this time 0. 3, -1, and 0 would all have made that bottom part equal to 0. So we'll exclude those from the domain. We could do the AC method here. I'm just going to take a stab at it using sort of the guess and check. I think I got it. And again, because I made it into factoring, it's multiplied now, and I'm allowed to reduce. So I've got the 4 over x plus 4. Some people are tempted to reduce those 4's. The reason you can't reduce the 4's is because there's addition down there, so don't be tempted. And then the domain is all real numbers, except those x values that would have made that 0. So -4 for sure, and -1/2 would have made that canceled factor 0. All right, when you add or subtract fractions, you have to have a common denominator. And right now, these denominators aren't the same. They're almost, shouldn't call them opposite, but basically what we're going to do is multiply this one by this fancy 1, right? You can multiply the top and bottom of the fraction by the same number and not change its value, because you're really just multiplying by 1. Anyway, do you see what's going on now? Now I have the same denominator for both fractions. So we're going to have one big fraction with x minus 2x plus 2 on the bottom. And on the top, we'll have the 6 with the x minus 2 plus the 3 with the x plus 2. And then we'll just distribute and simplify on the top there. The moral of the story is we're trying to get a common denominator when we're doing the addition and subtraction ones. I get lazy sometimes and don't write the entire denominator until I'm ready for the final answer. You could FOIL out this bottom part. X minus 2 and x plus 2 would FOIL it to x squared minus 4. I always like to just check to see if I can factor the top a little bit. It doesn't look like anything would cancel top and bottom, so this could just be a final answer. Again, I could leave the top factored, I could FOIL out the bottom, either way is fine. Number 8, I know on the last one I just multiplied them by each other, but did you notice on number 8, this is already an x plus 5, x minus 5, the x squared minus 25. So really, if we just give this one an x minus 5, then the denominators match. Common denominator x plus 5, x minus 5. On the top, we have the x plus 3 plus the x times x minus 5. We'll simplify the top. And then just to make sure that I can't simplify that anymore, I like to check to see what that top would be factored. X minus 3, x minus 1. Wouldn't allow me to cancel anyway, so I can leave it like this. I can keep the top factored, FOIL at the bottom. Doesn't matter to me. And I have a partial answer left on there. We're trying to get a common denominator for these guys. I am not allowed to do a plus 4 on the top and bottom here. Seems like it would work nice, but you're not allowed to add the same number to the top and bottom. One way I explain that is, like, if we had the fraction 1/2 and we tried to add a 4 to the top of the bottom, we'd get 5/8. Is 1/2 the same as 5/8? No. So the moral of that story is we are not allowed to add the same number to the top and bottom. What we can do is multiply the same number on the top and bottom. If I did times 4 and times 4, it's kind of like multiplying by 1, so I get 4/8, which is equal to 1/2. So the multiplying is the way to go. The reason I bring that up is because I can't do a plus 4 plus 4. So I'm going to do again how I multiply these guys by each other to get a common denominator. That's really the way we have to go on this one. So my common denominator is x times x plus 4. And I have a 3x squared. I'll distribute that 8x plus 32. And then I wanted to show you this trick. I was kind of wondering, can I factor that top thing? I wanted to show you the trick that if you do the b squared minus 4ac to that, I know that might be a stretch. It's been a while since we did that, but using the a, the b, and the c, I'd have 8 squared minus 4 times 3 times 32. I don't have a calculator with me right now, but I know that that winds up being a negative number. And if you think about when the quadratic formula has the square root of that, if this comes out to be a negative number, then I just know that that's not going to factor. In fact, unless this comes out to be a perfect square, if it comes out to be like 25, or if it comes out to be 81, then I know that I could factor this, but that's just a quick way that I can check to see if that'll even factor at all. B squared minus 4ac, if it comes out as a perfect square, then I know at least I should try to factor it. It will factor. This one doesn't factor. It became a negative. Not only was it not a perfect square, but it was a negative, so that would be my final answer. I can't do any more than that. All right, number 10. This looks awful, but if we factor first, again, I could use the AC method here. I think I can take a stab at guess and check, and I think I did okay. So now that we see that, I can tell that they already have the x plus 3 in common. So if I just give this one a 2x minus 1, and I just give this one an x minus 2, then the denominators will match. Altogether, that will equal, this is a beast, that's our common denominator. On the top, I'd have 5 times this one, so 10x minus 5, and 5 times this one, 5x minus 10, and I'll simplify that top. Thinking of factoring out the 15 upstairs, but I knew there wasn't an x minus 1 factor on the bottom, so I could take it or leave it. Number 11 is our first subtraction one, so I tried to take it easy on you. Did you notice the denominators are already the same? So we have a common denominator already. The thing we have to be careful of on these is like when we subtract the numerators, make sure you're subtracting the entirety of the second one, or in other words, put it in parentheses, because you have to subtract the x and subtract the 3. It's like that it distributes. So we'd be having a 2x plus 5 minus an x and minus a 3. That's easy to miss if you're not paying attention. That subtraction sort of has to distribute. Simplify the top, and I'm all done. And I still had some work here. Try to ignore that. All right. Subtraction again, so we'll want to be careful about some parentheses in there. This is one of those perfect square trinomials. It factors to x plus 5, x plus 5. If I factor out a 2 on this one, I am thinking that this one's going to need its own 2. And this one needs an extra x plus 5. And then they will match. Common denominators. All right. And we're subtracting. So on the top of this one, I'm going to have 2x plus 6 minus, and I'm going to have to FOIL out the x plus 1 times x plus 5. All over that common denominator. We'll get to that. All right. The thing is, though, when I FOIL this one, I'll want to remember that when I'm done foiling, I need to distribute that minus into the whole thing. So maybe I'll just FOIL it off to the side over here. X squared, outside, inside will wind up being 6x plus 5. All right. So the top has the 2x plus 6, but then I'm going to distribute the minus to all 3 of those FOILed out pieces. So it'll be a minus x squared, a minus 6x, and a minus 5. All over that common denominator. I think I'm about ready for my final answer. negative x squared minus 4x plus 1 all over, do you even remember what the common denominator was? The 2 times x plus 5 times x plus 5. I totally could have written that as x plus 5 squared. I'm thinking the top is not going to factor, so nothing will simplify more, and I can be all done. Moving on. This page is way easier. Do you know why? Because when we multiply fractions, we don't need a common denominator. We just multiply straight across. So we'll multiply the numerators. We'll multiply the denominators. And then as long as nothing's canceling, remember this is all multiplication, so we have a chance to cancel at least. And it doesn't really cancel. I might just distribute the x because it feels like something I should do. Well, that would be a nice final answer. So just multiply straight across. Maybe simplify it if it feels right. 14. Sometimes I will just extend this line because isn't that what's going to happen anyway? I'm just going to multiply the tops and multiply the bottoms. What I am noticing is that on the top I've got an x minus 1 times an 10 times an x. I separated those for a reason. Downstairs I have a 5 times an x times this will factor into x plus 1, x minus 1. So that was just multiplying straight across, did a little bit of factoring, and now I can see that I have some cancellations I can do. Since it's multiplication, I'm allowed to cancel. Those x's go away, and then I just reduce the 10 over 5 like I would a normal fraction. And we see what's left, just the 2 on the top, just the x plus 1 on the bottom. Way easier than adding and subtracting, I think. So the general rule is that you want to try to factor. Factoring is the only way we can get things to cancel. All right. And these are multiplied, so you can just think of that as being one big top and one big bottom. I have the x minus 5's canceling. The 7 over 2 doesn't reduce. And the x plus 2's are both on the top. If they're both on the same side of the fraction, they don't cancel out. It's only when you take something divided by itself that it cancels out. So I've got an x plus 2 times another x plus 2, if you want to write it like that. And on the bottom, we've got this. And I'm just not going to be picky about whether we expand that out or whether we leave it factored. Either way is fine with me. Number 16. Did you notice these two have a common denominator? Not that it really matters. We're still just going to multiply straight across. So 8 times x plus 1. And you do have to multiply these. If that was adding, I would only have a single x plus 3, the common denominator on the bottom. But in multiplying, we do multiply straight across. So we multiply both. And nothing really cancels out. I'd be okay with leaving it like this. Or if you wanted to distribute, 8x plus 8, FOIL the bottom, x squared plus 6x plus 9. If you like the looks of that better, I'll take it either way. All right. I'm really glad we're doing number 17. It reminds me of, remember the difference of cubes factoring? I'll just write the formula up here. Your job was to memorize this formula eventually. I usually remember it starts with an a minus b because it kind of looks like an a minus b to start. And then the other factor has an a squared here and a b squared here and an ab in the middle. And when the minus is here, the minus goes here, and these are both plus. You might want to study the other one, the one that has a cubed plus b cubed. So this is a difference of cubes. Can you tell what the a and the b equal? What's cubed to make this? X is cubed. What's cubed to make this? 3 cubed makes 27. So when I go to factor this buddy, I am just going to be plugging in an x and a 3 for all of my a's and b's in the formula. A minus b, a squared plus ab plus b squared. So that's the factored form of x cubed minus 27. And then we'll remember that that's multiplied straight across, so I'll multiply by this x2. On the bottom I have an x times an x minus 3. And I get some great canceling going on. So satisfying. Beautiful. This is our first division one. If you remember how to divide by fractions, dividing by a fraction is the same thing as multiplying by the reciprocal. So I'm going to rewrite this. So it'll just be the normal fraction x plus 5 over x squared plus 16. By the way, you can't factor when it's x squared plus 16. If that were x squared minus 16, it would be x plus 4x minus 4. But with the x squared plus 16, it does not factor anymore. And now I'm going to do my division. So division is the same thing as multiplying by the reciprocal. So I just flip that second guy over. And now I can see that since we have multiplication here, I've got an x plus 5 and an x plus 5. That'll cancel out. On the top, just a 4x. On the bottom, an x squared plus 16. We can't reduce the 4 and the 16 or the x and the x because we have that addition down there. So that would be our final answer. Another division one with some fun factoring. These numbers look a little big to me, so I might try to use the AC method. Unless you can play guess and check on it. 28 is probably 7 and 4. 7. Oh, maybe I do have it. If we make this one positive and that one negative. I think I got. Go ahead and do the AC method, but I think that worked out. Yeah, that's right. All right, so I got that factored. I have to remember that I'm going to multiply by the reciprocal, so maybe I should rewrite this. First one stays the same. I only flip the second one, so this is going to flip reciprocal. I'm going to factor out that 2 while I'm at it. Beautiful. Division. Multiply by the reciprocal. We got some cancellation. So good. And so it looks like all we have left is the 2 and the 3x minus 7 on the top. Nothing on the bottom. I could put this over 1, but whatever. I kind of want to distribute that to 6x minus 14. Sounds good to me. Oh, a last one. We can do this. So we've got a division. So I'm going to multiply by the reciprocal on that one. So I've got a 3 plus x over x minus 4 times. Oh, question. Is 4 minus x and x minus 4, do those cancel? The answer is no, because technically 4 minus x is the same thing. That negative belongs to the x. So if I were to rewrite this in sort of standard form, that would be a negative x plus a 4. So those don't quite cancel. What you can do, though, stick with me on this one, you can factor out a negative 1 from there. If I take the negative 1 out of there, if I undistribute it, can you see how if I redistribute, I'd have a negative x plus 4? The moral of the story is if you ever have things that are like, they almost cancel, but they're like opposite of each other, try that trick of factoring out a negative 1. That's the ticket. So they will cancel, there will just be a negative left over. I'm dividing this one, so I have to remember to flip it. X squared minus 9 factors. All right, and all of this is just going to be one big fraction, so I can look for my canceling now. So I have the x minus 4's go. Now x plus 3 and 3 plus x are the same thing, because I can rearrange addition, no problem. I know this looks like a 2x squared and a 3x squared, but remember, those are just multiplied together, so we can cancel just the x squared part. I think that might be it. What do we have left on the top? A negative 1 times 2, and on the bottom a 3 times an x minus 3. Feel free to distribute that if you like. Either of those would be just great. Thanks for watching.